Airflow and duct design are super important when it comes to the HVAC industry. The most common problem in the industry is airflow, especially when I'm doing service out in the field. And when you have a new install, new equipment on old ductwork, I have issues with airflow always. If you want to learn more about airflow and duct design, to learn how to do the calculations, the formulas that I use to tell CFM on a brand new startup, to be able to tell BTU, today I'm going to go over that. What tools I use, the measurements that I take. It's a very simple formula, and I actually learned this when I started doing a TVA inspection checklist for heat pumps. So I want to show you that. I also want to give you the airflow and duct design guide, and by the end of the video I'm going to show you how to get that guide if you want to learn more, if you want to have this so that you can be more proficient in the field. So first things first, let's go ahead and look at the inspection checklist. And the reason that I want you to be able to tell CFM and BTU on the job is because if you're a technician and you know how to do these calculations, then you're going to basically make the other technicians look like they don't know what they're doing. And this is something that I ask new interviewers or new employees. I ask them, hey, do you know how to use an anemometer? Do you know how to tell CFM? And today's video, I'm really looking forward to being able to give you this information because this is what set me apart in the field. I was able to go to the house, brand new startup, 36,000 BTU unit, and I was able to tell the customer, hey, it's putting out 1100 CFM. We need to do this. We need to up the airflow. We need to decrease the airflow. That way we can get the more temperature split. So let's go ahead and get started, guys. The first thing I want to do is I'm going to show you this right here. This is the heat pump installation inspection checklist, all right? And what I want to show you is this is where you would put your readings for your feet per minute, okay? And you use an anemometer, okay? If you don't know what an anemometer is, you definitely need to look that up. I've got other videos showing you what an anemometer is. Anemometer is a tool that has a little propeller on it, a fan, and it measures the feet per minute across the return grill, okay? The return grill is where your filter goes. And this right here is where you'd put your readings down, okay? And I've already taken my readings. I've got this over here for you, so you don't have to take any readings to figure out how to do this. And I'm going to show you the training guide here in a minute. It's a really awesome training guide, and it shows you how to make these calculations too. But let's go ahead and go over this real quick. So I'm basically going up to my return grill, 20 by 30. It's got 4 grates, and I'm going to take 16 to 20 readings. Okay, you can take more if you want, but we're going to do 16 readings. I've got my length of my grill, which was 30, and then my width, which was 20. So it's a 20 by 30 return grill, right? All right, now this is the actual calculation. If you want to write this down, write it down. This is how you figure out CFM. What we want to do is, the first thing we want to do is we want to take our readings with our anemometer to figure out our average feet per minute, okay? Once we figure out average feet per minute, then we can put that in this formulation to figure out CFM. Why is it important? Because if you have a 1200 CFM 3-ton unit and it's not putting out 1200 CFM, you can figure that out, okay? Then you can figure out what you need to do. So we take our average feet per minute. I took 16 readings and they're all 300, okay? And I did this just for an example. So I took 4 readings, 1 on each grate. These 4 readings were 300, these were 300, these were 300, these were 300, and then I take and add them up. Now, they're all the same, so our average feet per minute is going to be 300, okay? But what you would do is you would add all your readings together. They would be different, and then you would divide them by the number of readings that you took, okay? Very easy. You add all these together. You add all these together, very easy, and then you divide them by the number of readings that you took. 4,800 is what it comes up to when I add all these together, and then I divide it by 16, and then it equals my average feet per minute, which is 300. Easy, all right? Now, taking into consideration, you know your length, you know your width of your return grill. Now you can go to the formula. So I've got feet per minute right here, 300, times by 0.75, which was the average surface area of the grill, times by your return grill, 20 by 30, and then you divide it by 144. So if I times all this together, 300 feet per minute times 0.75 times 20 by 30 return grill, I'm going to get 135,000. When I do that, I divide it by 144, okay? You divide it, all this here by 144, and that equals your CFM. And when I divide this right here by 144, I get 937 CFM, okay? So now, if I have a 1200 CFM equipment, 400 CFM per ton, 3-ton unit, and I got 937, I know something's wrong. I know my airflow's not enough. If I get more than 500 feet per minute on my return grill, on feet per minute, on any of these readings, I know it's too much, okay? If I get less than 300, 250, it's way too low. I know I need to up my airflow, okay? So these are rules of thumbs, but guys, this is where it's at, okay? Now, 937 CFM. Now, what do I do to figure out my BTU? Very simple, all right? We're gonna go down here, and I'm gonna show you. There is a formula. All you do is you take your CFM, which was 937, you times that by 1.1, and then your temperature split. Okay, your temperature difference. Now, where do you get temperature difference? You know where you get temperature difference. Let me talk to you for just a sec to this. So the way you get temperature difference is you have your temperature measurement tool. I use my meter and then the thermistor that comes with it, or I have a dual port In-Duct psychrometer I use, and I measure my supply, okay? And then I measure my return. And after I take those measurements, I have a temperature difference. Now, my supply temperature may be 95 degrees and my return temperature may be 70, okay? That means I've got a 25-degree difference. My return temperature may be 70 and my supply may be 50. I got a 20-degree difference there, okay? So that's very easy. I've actually got videos on that, but what do? We take 937 CFM times 1.1 times the temperature difference, which is 20, and then it gives me BTU. So 20,614 BTUs. Look at that. So you're able to figure out what your BTU is of your unit. If it's rated for 24,000 BTUs, man, I'm almost there. Look at that. I mean, I can probably increase airflow to change the BTU. I can decrease airflow to change the BTU, to change the CFM. But this is a great way for me to know, hey, is there something I can do as far as adjusting on the equipment? Or is it the actual ductwork that I need to take into consideration that there's something could be wrong? If you want to know how to use a ductulator, go check out my video on how to use a ductulator. If you want this design guide here, this airflow and duct design guide, then I suggest that you comment down below. Let me know that you've become a member, okay? Because if you're a member, you're going to get this guide, all right? And it talks about reduced plenum systems, sizing down every 30%. You take off the system, you size down, that increased static, how to use a magnehelic, taking magnehelic measurements, where to take them. You need to know that. Airflow is so important. So first, to get the design guide, you just become a member. Very easy. You comment below, you let me know, hey, I'm a member. I'm going to give you my email. Then I'm going to be able to send you that airflow and duct design guide. Super simple. You get the design guide and you increase your knowledge. And this is something in the field that I learned when I was doing the TVA inspection checklist. It was a very, very awesome experience for me, because I was really doing the due diligence for not only the customer, but I was doing the due diligence for myself to be able to understand more and how I could change the airflow speed and up the CFM quickly. And there are feet per minute that and I actually mentioned this earlier in the video, is that, on the return grill, which is where your filter is, the air pulls, across the return filter into that grill and in the return side of the duct, you shouldn't have above 500 feet per minute. If you got 600, you're in big trouble. You either got a duct that is very restricted, you've got a filter that's not clean, or your ducts just need to be redesigned, altered, modified so that you don't have that type of feet per minute. Maybe you don't have enough supply. And remember, you can never have enough return, okay? But if you don't have enough return, you will never have enough supply. Now, you need an anemometer, okay? You need a magnehelic. You need a temperature probe to be able to measure the temperature. You need to check temperature difference. That's something in the field that you should be doing. You know that the temperature difference is something that's always changing. Usually you hear people say, I say 18 to 22 degree is a good split. And usually that's what I find in the field, but you might not have that because of the design of the ductwork, because of the equipment, and just the way everything's laid out. It may be 16. That may be all you can get. But you need to know these things because it's going to make you more proficient in the field. I'm Tad. You're watching Tips for Technicians. And just reminding you, I'll keep you cool if you let me. Thanks for watching, everybody. Definitely don't forget to subscribe, like the video.